Hello everyone. In today's video, I'll start a new chapter called slope deflection method. So before going to the topic, I would like to highlight some of the basics of slope deflection method. So here, you can see here it's a fixed beam and one load is acting upon this beam. Okay, so now if you want to find the moment about A to B, I'll write it down. So now if you want to determine moment about A to B, okay, suppose this is A point and this is B point, then we have to use this formula. Okay, moment about A to B is equal to MABF plus 2EI by L bracket 2 theta A plus theta B minus 3 delta by L. So if we want to determine the moment about A to B, then we have to use this formula. That means moment about A to B. Here we have to, I'll write it down, we have to use this formula while going from A to B. Use this formula while going from A to B, or we can say that it's a left to right. Okay, now we have this formula with us, this formula. Okay, now if you want to find the moment about I'll star mark it. Now if you want to determine moment about B to A, then we have to use this formula. B A is equal to MBAF plus 2EI by L 2 theta B plus theta A minus 3 delta by L. Okay, so this formula will use while going from B to A, or we can say that, okay, use this formula while going from B to A, or we can say that right to left. Okay, now see, for this particular beam, if you want to determine the moment about A to B from this point to this point, then we have to use this formula. Okay, and if you want to find the moment from again B to A, that means from left to right, then you have to use this formula. So both the formulas are very important, and just see the difference between this formula is, just you have to remember this formula. Okay, that is moment about A to B. A to B you have to find, then you will write from this A to B, AB. Okay, here this MABF, it's a fixed end moment about AB. I'll explain you in detail later this part. plus 2EI. 2E is nothing but the moment of, this is the Young's modulus or modulus of elasticity, and I is the moment of inertia, and L is the span, and theta is the slope, and this is the delta is the deflection. Okay, now this formula say if you have to find from B to A, then this both the formulas are almost similar, but whenever it says you have to find from B to A, then you only need to change this formula was A to B, that's why it's AB. Now you have to find from B to A, so it will get changed, B to A. See, now everything will be B to A. This one fixed end moment from B to A, it will be B to A, and this before A to B, the 2 theta A was there in the initial, but here theta B will be in the initial, and this will be in the second, A will be in the second. Okay, so this is the way of remembering this formula. Now here now for finding the fixed end moment, okay, this is the fixed end moment about B to A. So fixed end moment, we have to remember some of the formulas. Now I'll explain you. And while calculating FEM, okay, FEM is nothing but the fixed end moment, okay. So while calculating FEM, we have to consider some of the points. So now suppose see, here one end is fixed and the other ends are hinge support, and these are also hinge support. But in case of the fixed end moment, always we have to consider that all the points are fixed, okay, but we have to consider only in case of fixed end moment, right? Now these are the important terms which you have to remember, okay. This fixed end moments. So for the fixed end moment, this is 1, okay. Suppose it's a fixed end, and here W is loading, and this is the length. So the bending moment diagram will be like this in this case, right? And what will be the maximum bending moment formula will be WL by 4, right? So now here for finding the fixed end moment about A to B is equal to minus WL by 8, and if we have to calculate from B to A, the fixed end moment will be positive WL by 8. These things you have to remember, okay. Now in case of, suppose it's a fixed beam and here one load is acting, here the distance is not same, it's not equally distributed, okay. So this distance will considered as A and this will considered as B, and the bending moment diagram will be like this, right? It's not equally distributed, okay. So here the maximum bending formula will be WAB by L. Now for this type of case, if you have to find the fixed end moment from here AB, this will also AB, okay. So AB, then the formula will be minus WAB square divided by L square. L is the total length, okay. Now if we have to find from B to A, the fixed end moment is equal to, it will be positive WA square B by L square. Okay, now the third case, suppose it's a fixed beam and UDL is acting on this beam W, and this is the length. So the bending moment diagram will be like this, and the maximum bending moment will be WL square by 8. So here, for finding the fixed end moment from A to B, the formula will be minus WL square by 12, and fixed end moment from B to A will be positive WL square by 12. Now the fourth case is, suppose it's a fixed end moment and one moment is acting here M, and the distance from here to here is small a and here is small b. Let it be capital A and B. So here the bending moment diagram will be like this. Okay, and the maximum moment upper side will be MB divided by L, and the lower will be MA divided by L. So here fixed end moment from A to B is equal to MB bracket 2A minus B divided by L square, and MBA fixed end moment from A to B, B to A will be MA bracket 2B minus A divided by L square. So these are the formulas for finding the fixed end moment which you have to remember, and this plays a very important role in finding the slope deflection method. Okay, okay, so now we'll go. Now I'll write down some of the steps of SDM. Okay, SDM is nothing but the slope deflection method, the steps to be followed. Here I'll write down the steps to be followed in slope deflection method. Sorry, SDM. Okay, so here the first step is to find fixed end moment. Fixed end moment, that means suppose fixed end moment for, it can be a AB for AB, BA for BC and CB. Suppose it's a continuous beam. Okay, A, B, C, D. So you have to find for each span, right? So fixed end moment from A to B, again B to A, again B to C, C to B, and here C to D and D to C. Now second step is to apply slope deflection method. Okay, slope deflection method, or we can say that apply the slope deflection equation for each span. So here the slope deflection equation, we have a formula for slope deflection equation was, I have already written in my previously also I have written. So here that is MAB is equal to MAB fixed end moment plus 2EI by L to theta A plus theta B minus 3 delta by L. So this is the slope deflection equation, and here BA is equal to MBA plus 2EI by L to theta B plus theta A minus 3 delta by L. Okay, so here in the second step we have to apply this equation for each span. Okay, now step 3. So step 3 is to apply condition of equilibrium. Apply condition of equilibrium. So we have two conditions here. Suppose for a fixed beam and internal one hinges there. So here this is the AB. Okay, so for this type of beam we know that if we suppose take it as A, B and C. So here if we take moment about B to A plus moment about B to C, will always get 0, and this is our first condition. And the second condition is, suppose the end is not fixed. Okay, end is simply supported and the middle is roller. So suppose A, B, C, and we know that for a simply supported beam the moment will always be 0. So here at A point and at C point the moment will be 0. So moment about A to B will be 0 and moment about C to B will always be 0. Okay, so this is our third step, and fourth step is to find the final moment, and fifth step is to find support reactions by separating the span, that is can be a AB, B, C, C, D. Okay, and the sixth step is to find final support reactions, and the last step is to draw SFD and BMD. SFD is nothing but the shear force diagram and BMD is the bending moment diagram. Okay, so now in my next video I'll start to solve a problem based on slope deflection method. Thank you.